Oh, okay, going to start the class. Okay, today we'll discuss another numerical problems, and those are those very similar to the problems we have solved in the previous class, but the main difference is that the characteristics of the soil. Now, coming to the previous problem that we have solved in the last class, this one was the last problem we have solved, and the height of the wall was 6 meter, and the backfill soil was sand, and the sand is characterized by these characteristics, that is equals to 0, and there was a value of phi and gamma. Today we'll discuss similar type of problem, but the characteristics of the soil is that where the C, or the cohesion of the soil, is given as 50 kilonewton per meter square, and the phi of the soil is given as 0 degree. These are the main characteristics of soil, and the previous problem is related to the sandy soil or cohesion less soil. This problem is related to the cohesive soil or clay soil, that is a vertical wall of 6 meter height has clay soil behind it. There in the previous problem, the soil was sand, pure sand or cohesionless soil, and the clay soil is characterized by this property, that is equals to 50 kilonewton per meter square, phi equals to 0 degree, and gamma equals to 80 kilonewton per meter cube. Now coming to the solution, this is the figure, that is the height of this wall is 6 meter, total height of this wall is 6 meter. You may write here these these characteristics or these values, these data which is given as the characteristics of the clay, you may write down here as the property or the characteristics of the backfill soil. Okay. Now coming to the previous lessons we have discussed in the previous classes, that is the equation for active earth pressure for cohesive type of soil. That is, this is the general equation for the active earth pressure. This is the sorry, this one is minus and this one is plus. Uh, General equation for cohesive type of soil, that is the active pressure for a general type of soil where the value of C and phi is given, and these general types of equations we can use for the problem we are going to discuss. And this one this one is the equation for cohesive soil where the value of C is not equals to 0. That means there is a value of C given. Now we may take this equation as that was. Okay, this is the equation for cohesive type of soil with a value of C not equals to 0. Now another thing is that is the value of Ka. This is this one, the value of Ka, which is the coefficient of earth pressure at active condition, or coefficient of active earth pressure, which is equals to 1 minus sin phi divided by 1 plus sin phi. Now here we have to uh, calculate the value of Ka, and here the value of phi is given as 0 degree. This is 0 degree, and this one is also 0 degree. Okay, now we know the value of sine 0, that is 0, and the coefficient of active arc pressure is here 1 as the data provided. Now coming to the equation, this one you have to put the values of all these parameters, where Ka equals to 1, gamma equals to 18, H equals to 6. For your convenience, you may use the multiplication sign, or you will confuse with the decimal point. The value of C is 50 kilonewton per meter cube, and the value of Ka is 1. Now you may calculate, that is this equals to 108 minus 100 equals to 8 kilonewton per meter square. This is the value of the earth pressure at the base of the wall. I am starting to write down the value, what is 8 kilonewton per meter square. I am making it bold so that you can see the value easily, that is the value of earth pressure at the base of the wall is 8 kilonewton per meter square. Now this up to this is similar to the previous problem as the cohesionless soil. Now coming to the next part of this problem, that is you have to This one is at the bottom of the wall. PA at the bottom of the wall is this one. Now the difference of this problem from the previous problem is, sorry, PA at top of the wall. That means active arc pressure at top of the wall is equals to, the equation is same, but the value of Ka is 1, same, value of gamma is 18, and finally the value of H is equals to 0, because the value of the depth at the top of the wall, from the top of the wall, is 0, same point. Here the value of the depth of soil at the bottom of the wall is 6 meter, but at the top of the wall is, this one is 0. This is 50 multiplied by root over of Ka, and the value of K is 1. Now here making the calculation, this one is 18 minus 100, and that is what, 82 kilonewton. Sorry, this one is 0. Sorry, 1 multiplied by 18 multiplied by 0, this one is 0, and this one is 100, but the sign is minus, minus 100 kilonewton per meter square. Then coming to the arc pressure diagram, that is, this one is 8 kilonewton per meter square, but at the top of the wall is 100 kilonewton per meter square. If we try to draw the pressure diagram, that is, at the top, this one is negative pressure. If this direction is positive, positive 8 kilonewton per meter square, this direction will be negative, negative pressure, and the value is 100 kilonewton per meter square, so higher than that 8 kilonewton per meter square. And as there is no other data, no other changes in the soil is with same characteristics throughout the depth, then we may join these two values to complete the arc pressure diagram. If you want, then this line of retaining wall may be erased, and this is the arc pressure diagram for this case. At the top of the wall, the pressure is negative 100 kilonewton per meter square, and at the bottom of the wall, that is positive 8 kN per meter square. This pressure is acting like this, and this pressure is acting like this, from this way and from the opposite way. Both the shape, both the shape is of triangle, and the acting point of this force, and this force is at from the CG of the triangle. That means if this is the this up to this is the height of this triangle, this position of this force is one third of this height from the top of the wall, and this one, the position of this force is one third from the bottom of the wall. And you may calculate the active thrust or active force separately for this negative pressure and for this positive pressure, but for that you have to calculate this point, the position of this point. Now you may derive a general equation for this point of where the earth pressure or the active earth pressure is 0. From this equation we may derive one equation for the position of this point where the active earth pressure is 0. Now if we consider this depth as z, this depth up to the point where the active pressure is 0. This point is 0. This is positive, this is negative, and this point is 0. Up to this point, this is 0. If we consider this depth as z, then we have to put the value of 8 is equals to z, and at at z, depth of z, the value of PA equals to 0. That means for this equation PA equals to 0, Ka gamma will be there, and H will be Z minus 2C root over of Ka. This will be the final modified equation you may write down if the active earth pressure at a depth z equals to 0. Therefore, Pa is equals to 0 and H equals to Z. From this modified form, we have one equation for Z, and that is 2C root over of Ka divided by Ka gamma equals to, sorry, this one is K suffix A, and that is equals to 1 root over of Ka will be normalized, and this one will be root over of Ka. This is the general equation for this Z, this depth Z, where the value of active arc pressure is 0. Value of active arc pressure is 0. Okay. Now, as the value here is 0, you may write this Z as Z0 or Z0, and this one is one of the important equation for this chapter. And if you have to derive one equation where the active thrust or active force, not active pressure, active thrust or active force is equal to 0, then that you may denote that as H0 or H naught, which is equals to the point where active thrust or active force equals is 0, and the depth of that point is equals to 2 of Z0, twice of Z0, and 2 of this one. That means 2 multiplied 2 is 4. 4c divided by Ka gamma. And these two equations, if we consider that type of soil where the value of phi is equal to 0, that means in this problem where the phi value is 0, then Ka is equals to 1, and for that type of soil which is pure clay or pure cohesive soil where the value of K is equals to 0, then Z0 is equal to 2C by gamma and H0 is equals to 4C by gamma. Please remember that for pure clay or cohesive soil, pure cohesive soil, Ka is equals to 1. For your convenience, I may write here C, sorry, phi is equals to 0. 0 degree should be written. K is equals to 1. Then this is equals to the value of K is equals to 1. That means Z0 equals to 2C by gamma and H0 where the active thrust is 0. The depth of that point is 4C by gamma as the value of Ka equals to 0. Sorry, K is equals to 1. Now, this is the derivation of these equations. Now, we may put the value to find out this value Z for this problem, and Z0 is equals to 2C by gamma, and C is equals to 50, gamma is equals to 18. We may calculate the value, and that should be, you may calculate your own. That is 100 by 18. Most probably this is 5.5 or 5.6 meters. That means most of the height, almost the full height, 5.6 meter, there will be a negative pressure. That is, that pressure is acting from this way to this way, and this is the special for due to the special characteristics of pure clay or cohesive soil. And at the bottom of the wall there is a small region where positive pressure is acting from this side to this side. Okay, now now last part of this problem, that is active thrust, that is capital PA. That is same the area of this pressure diagram. Here two triangles are there, one is negative and one is positive. Just sorry, this portion should be after this. Active charge PA equals to area of summation of the area of two triangle, for this case half of 5.6, that is the height of this triangle, the value of Z 5.6 multiplied by base of the triangle is 100. Base of the triangle, this length is 100, and the total area is negative. Now coming to the positive part of pressure, and that is similar. Half multiplied by the rest part of the wall is the height of this triangle, that is 6 minus 5.6 multiplied by the base is 8, that is this length is 8, and this height of this triangle is rest of the wall, that is 6 minus this part, the length of this part is 5.6 meter. You may calculate, that is minus 280, I think, plus 1.6, I think, and the value is minus of 278.4 kilonewton per meter length of the wall, and this case is when the upper negative part is considered, and this upper negative part is considered when there is no crack. Crack means this much of soil, this part of soil will dislocated or separated from the wall. When there is some clay characteristics in the soil, then after some pressure, after some value of pressure, this much of soil up to this point will make a crack or separated from the surface of the wall. If there is no such type of cracks, then this is the way to calculate the active thrust, or the point of zero active thrust. This is the way. But when there is crack, when you have to consider some cracks are there, that is, this much of soil is separated due to this negative pressure. This much of soil is separated from the surface of the wall like this, due to the this negative pressure acting from this way to this way. That means this soil will separated like this. The soil is then is not connected to the wall, okay, like this. Then when cracks generate, then active thrust PA equals to only this part. That means we have to ignore the negative pressure. We have to ignore the negative pressure in the calculation of active thrust when cracks generate at the top of the wall, and that is equals to, for this case, kilonewton kilonewton per meter length of the wall, and the length is the dimension perpendicular to the screen. The length of the wall means the dimension perpendicular to this length. This is height and this is width, and this is this is height, this is breadth, and the width is actually considered as length of the wall. The length may be, these types of wall may be a long wall or maybe a short wall, but we have to consider this length. The dimension perpendicular to the screen will be the length, and the per meter of length of the wall is that dimension. Okay, now this is the full problem of this type, where the value of C is there and value of phi is 0. That means purely cohesive soil or pure clay is there in the backfill soil. Now, now I am giving one problem for your assignment. Same problem, but I am changing some data. That is, the value of C is 5 kN per meter square and the value of phi is 20 degree. That means here The characteristics of soil is having C value and phi value both, and the soil may be named as C phi soil. C phi soil behind it, the surface horizontal. Other parts are similar. Only you have to determine the distribution of active earth pressure and total lateral force or thrust on the wall per meter length of wall. The characteristics of the soil is this. I'll send this problem in the Google form. What that I send for your attendance. In that form, I'll send this problem. Please try to solve the problem. No worry, I may discuss this problem in the next class also. If there is any problem, any doubts in solving the problem, please try to solve this problem yourself and just write the answer you will get after solving it in the form. Okay, you may solve. Yes, anyone want to say something? Okay, okay. Please try to solve this problem yourselves and write down the answer of the active thrust, the value of the active thrust, considering there is no crack in the soil. Then the value of total active force or active thrust you have to write down in the answer, and the difference is that only you have to calculate the value of Ka, coefficient of active earth pressure, with the value of phi equals to 20 degree. You have to calculate this value. This value is different in this problem and the problem we have discussed. Okay, you have to calculate the Ka considering phi is equals to 20, and you have to consider a different value of C, which is 5 kilonewton per meter square. After that, you have to draw the earth pressure diagram. That earth pressure diagram will be different from that, and finally you have to calculate the Z0, where the active earth pressure is, value of active earth pressure is 0, and finally you have to calculate active thrust considering there is no crack formed at the connection of the wall and the soil. Okay, okay, okay. Then I am stopping the presentation right now. I'll send this problem in a Google form. Just try to solve and write the answer on the Google form. Okay.